Copper is one of the top 7 metals known since the ancient time. Actually, humankind knows over 170 copper-containing minerals. Copper melts at 1083 Celsius degrees. Copper and zinc alloy is known as brass. Copper and tin give us bronze, and alliance with nickel turns copper into mercury. Copper presents in Olympic medals of 2 values. Bronze medal contains about 97% of copper and silver medal about 7.5%. However, we need our copper mined and processed first. The ore from Cars Minerals open pits is to be processed at newly constructed concentrators. First of all, mine trucks deliver the ore to the primary crusher. The capacity of the crusher receiving bin allows containing 2 trucks load. This crusher reduces the ore size by approximately 80%, then crushed ore is to be shipped to the concentrator via surface conveyor belt. The initial ore processing point at the concentrator is the SAG mill, where large ore lumps are ground rotating and colliding with each other and small amount of steel balls. Process water is to be added to the process at this stage. Do you know that operating mill sound may change depending on ground ore quantity and size? Uncharged mill produces higher noise level compared to the full load mill. A mixture of water and ores from SAG mills to be processed by ball mills, where quantity of steel balls is 5 to 10 times more. The ore is actually powdered here to feed flotation process in a liquid slurry form. Pneumatic flotation cells have been installed at new Cars Minerals concentrators to aerate the slurry. How it works? Metal minerals contained in the slurry float up to the surface, where they are flushed away through these special ducts. In order to recover different minerals from the ore mass, different chemical agents to be added to the slurry consequently. A final froth is collected in different cells with different metal concentration. All remaining mass on the cell bottom is known as a slime, or more simply, process waste that is to be collected in the designated area. Those are known as tailings. We know this high-concentration frothy mixture as a concentrate, but it is very inconvenient and expensive to ship liquid concentrate to the customers. Therefore, the concentrate is to be dried. The concentrate is packed in flexible big bags, 2000 kg of concentrate each in average. Copper grade in the dry powdered concentrate at Boschakol is about 20 to 28%. Approximately 940 big bags or 1,900 tons of concentrate or over 30 loaded rail cars are packed daily as the concentrator achieves the design capacity. And after several transformations at the smelter, it may turn into an Olympic medal, for example.
Copper is one of the most widely used metals. Nearly 12 million tonnes are used each year worldwide, mostly for electrical wiring, plumbing pipes, heat exchangers and coinage. About 15% of this is recycled copper. In this process, copper is refined from scrap copper and other copper-containing waste. Impure copper is melted in a furnace and cast into anodes for purification by electrolysis. During electrolysis, the anodes dissolve and pure copper is deposited onto stainless steel cathodes. This yields copper of 99.995% purity, which is then remelted and cast into billets. This high degree of purity is required for electrical use. At this site, the scrap material is collected and melted here. This building houses the electrolysis cells. Copper is remelted and cast into billets to be stored on this part of the site. Copper scrap is heated in a blast furnace with limestone, coke and air. This produces an alloy containing 80% copper and slag, which can be sold as an abrasive. Further treatment in 2 more furnaces produces 99% pure copper. This is cast into a strip, which is cut into anodes. This is the electrolysis cell room. It houses 288 cells and uses a total current of 24,000 amps. The copper anodes are sandwiched between stainless steel cathodes in sets of 39 anodes and 38 cathodes. They're placed in an electrolysis cell containing an electrolyte of hot sulfuric acid and copper sulfate. The anodes dissolve in the electrolyte to give a solution of copper ions, and pure copper is deposited on the cathodes. Impurities of other metals in the anodes do not dissolve and sink to the bottom of the electrolysis cell, producing anode slime. Anode slime is valuable and is sold so that the precious metal residues, including silver and gold, can be extracted. Once a week, the cathodes, with a 6 mm thick coating of copper on each side, are removed from the cells. The deposited copper is separated from the cathodes by flexing them and stripping the copper away with knives. The steel cathodes are then reused. Anodes last 3 weeks before being removed. About 12% of the anode remains after this time. These spent anodes are washed to remove further precious metal residues and recycled back into the anode furnace. Most of the pure copper from the cathodes is melted down in a furnace and cast continuously into circular sections of different sizes. These are known as billets.
Hayaang buksan ang isipan.